Hello friends, in this video I'm going to continue with my works on trigonometry, but we're going to focus on the angles of elevation and depression. But before we go into the calculations that are involved in angle of elevation and depression, I want us to understand actually what these terms are. Now supposing you have a horizontal plane here and you have a wonderful mango tree. Let's say that this is a mango tree and there is a ripe mango here, and the little boy is standing somewhere here and they're observing this mango tree. Look at the horizontal eye level of this side. This is the horizontal eye level, and for this boy to see this ripe mango, the boy ought to look up in order to see the ripe mango. So this angle here is known as angle of elevation. So angle of elevation is just that angle that is formed between one's eye level and the line through which you see an object that is above you. So look at the eye level of this side and look at the line through which the side is seeing an object above him. So this angle formed between these two lines are known as angle of elevation. So angle of elevation is observed when one sees an object that is slightly or more above him, but the other one becomes angle of depression. Now supposing you have still a horizontal line here and there is a mountain here, a mountainous hill somewhere here, and a boy is standing on this particular hill and observing a car on the horizontal ground. This is a car. So normally this is the eye of this boy and this is the eye level of the boy. And for this boy to see this car, the boy must bring down his eyes in order to see the object that is below him. So this angle formed here is known as angle of depression. So angle of depression is formed when you see objects that are below you. That is why we say that angle of depression is the angle formed between one's horizontal eye level and the line through which you see an object that is below you. Okay, and you can see that we form something that looks like a triangle here. Any angle that is here and the angle that is here must be the same thing because they are called alternate angles, since this particular line and this line are parallel to each other. Okay, now let us see how to use the trigonometric ratios we've learned in solving problems pertaining to angles of elevation and depression. Okay, before we go to problem solving pertaining to angle of elevation and depression, please, I want you to understand this, that if you have a right angle triangle like this, this is the right angle. The side facing the right angle is known as the hypotenuse. Assuming there is an angle here, theta, the side facing my angle is known as the opposite to that angle, while the third side is adjacent to the angle. So the opposite and adjacent do not have a peculiar place they stay in the right angle triangle. Their position are determined by the placement of the angle. If this angle theta is now here, it means that here is opposite while here becomes adjacent. But the hypotenuse must always stay here because it is the longest side of a right angle triangle, or the side being faced by the right angle. So having understood this, you should know the shortcut. Also, this will help you in dealing with problems pertaining to angles of elevation and depression. S stands for sine, so sine theta is the same thing as opposite over hypotenuse. Cosine theta is adjacent over hypotenuse, while tan theta is opposite over adjacent. By mastering all these things here, solving problems pertaining to angles of elevation and depression becomes very simple and easy for you. So let us go to problem solving. So look at the first problem we have here, which says that the angle of elevation of the top of a tree from a point 5 meters from the base of a tree 45 degrees is 45 degrees. Find the height of the tree. Before you do this, I want you to first of all draw the horizontal ground. You can assume that this is the tree standing, forming an angle of 90 degrees with the horizontal ground. And this is a point where the person is viewing the top of this tree, because the angle of elevation of the top of a tree from a point. This is a point. From a point 5 meters from the base of the tree. Look at the base of the tree. So this point to the base of the tree is 5 meters. Okay, and the angle of elevation, the angle through which the top of this tree is seen, is 45 degrees according to the question. And the question says we should find the height of the tree. Look at the height of the tree here, h. Now, to get the height of the tree, you should know that the longest side of a right angle triangle is the hypotenuse, while the side facing it is the opposite. The third side is now the adjacent. The side facing the given angle is the opposite. So we are having opposite over adjacent. Nothing is on the hypotenuse, so the hypotenuse is useless here. So we have opposite over adjacent. And from SOHCAHTOA, opposite over adjacent is tan theta. So you now tell them that tan 45 degrees is equal to opposite. Our opposite is h over adjacent, which is 5. Now, what is tan 45 degrees? Tan 45 degrees, if you check your calculator, it is 1. And you can call 1 over 1 equals h over 5. The reason I put over 1 here is to get a fraction, because this next one is a fraction, so that we can cross multiply. Because when you divide 1 by 1, you still get the value of 1, which is tan 45 degrees. So h times 1 is equal to h. Then 1 times 5 will still give us 5 meters. Which means the height of this tree is also 5 meters when the angle of elevation is 45 degrees.